Okay, so this is kind of more of the same, and yes, I heard somebody griping because it's a fraction, and it is, sorry. You'll be fine. All right, same kind of deal as yesterday, though. We're not really adding on or learning anything new, but I do think you guys need some more practice with me. So, domain, talking about x's. What can x not be? Positive and negative 2, right? So this domain goes from negative infinity to negative 2, and then it skips from negative 2 to positive 2, and then it picks up again at 2 to infinity. We save the range for the end, and you guys know I'm notorious for forgetting to go back and do the range, so help me remember. F of x, x-intercept. The x-intercept means that the y part is 0. So if we're setting a fraction equal to 0, we really just need to set the top equal to 0. Because if the top is 0, the whole thing is 0. So if I subtract 1 from both sides, do we have an issue here? Yep. Does this thing have an x-intercept? Nope. So none. To get a y-intercept, that's where our x is 0. So we take 0 and plug it in. I wind up with negative 1/4. So 0, negative 1/4. Derivative. Write small and keep it organized. Here we go. Booger T minus Taco Bueno. So bottom times the derivative of the top, which is 2x, minus top times the derivative of the bottom, which is 2x, all over the bottom squared. Then we just kind of clean it up. So we distribute and we get 2x cubed minus 8x minus 2x cubed minus 2x. Ever see where that minus 2x came from? I distributed a negative and a 2x at the same time. All over x squared minus 4 the quantity squared. Good news, we have 2x cubed minus 2x cubed. That's nice. Those go away. And negative 8x minus 2x is negative 10x. So it looks like to me like we found our derivative. So we can write it in the blank. Negative 10x over x squared minus 4 the quantity squared. The derivative is 0 for what x? What's going to make the top a 0? 0. It's undefined for what x? What's going to make the bottom undefined? Positive and negative 2. Good job. Where it's increasing, that's where we do our first derivative test. So what numbers go on this number line? 0. Anything else? Right. And I'm going to put little stars on these two guys because those are undefined. There's not actual points there, but they are critical to our graph here. If I take a negative 3 and I plug it into the derivative, I have a negative times a negative, so I have a positive on the top, and the bottom is definitely going to be positive because we're squaring it. So we wind up with a positive. If I put in a negative 1, same kind of process. It's going to give me a positive. If I put in a positive 1, the top becomes a negative over a positive is a negative. Put in a positive 3, the top is a negative divided by a positive, so we have a negative. So we have it's increasing from negative infinity to negative 2 and from negative 2 to 0. Why can't I just say from negative infinity to 0? Right, because at negative 2, there's not a point. It doesn't exist. We've got an asymptote right here. And if it helps some of you, could actually physically draw an asymptote every time, and that will kind of help remind you that there's a break in the graph. Decreasing, we are decreasing from 0 to 2 and from 2 to infinity. Local max, local min. So this, yes, is increasing, but there's a gap, and then we increase, decrease, and then we decrease. So what do we have here? What's that point? A maximum. At 0 comma something, and we don't have a minimum. How do I get to something that goes with the 0? Plug it into the original, because we're talking about where the maximum is on the original graph. If I put in a 0 in the original, I get negative 1/4. Second derivative. Okay, write small. The bottom times the derivative of the top, which is negative 10, minus the top times the derivative of the bottom, which is 2, times, leave the inside alone, the squared now becomes a 1. Now you need to finish the chain and do the derivative of the inside, which is 2x. Are there any questions with how I just did that? Okay, over the bottom squared, so I have x squared minus 4 to the 4th. All right, then I'm going to FOIL this first little piece so that I have x to the 4th minus 8x squared plus 16, and that whole thing is going to be multiplied by a negative 10. Over here on the right-hand side, I'm going to take 2x times 2, which is 4x, times negative 10x is negative 40x. Whoops, and we're subtracting it, so we're actually adding 40x squared. Does everybody see what just happened? And then eventually we're going to multiply that by x squared minus 4. And the whole thing goes over x squared minus 4 to the 4th. You guys okay at the front? Okay, let's multiply all these guys by negative 10. So I have negative 10 x to the 4th, negative 80x squared. Just kidding, thank you, good catch. Minus 160. Distribute the 40x squared, so we have 40x to the 4th plus 160x squared. Good night, yes. I should have recorded first hour. Didn't make those mistakes. Okay. On the bottom, stays the same. Then we put it together. With negative 10x to the 4th and positive 40x to the 4th, that gives me 30x to the 4th. We have 80x squared and 40x squared, that's 120x squared. Negative, whoop, just kidding, hold on. Yeah, I just put together the wrong thing. I've just made 3 mistakes in a row. 80x squared minus 160x squared is negative 80x squared. My bad. I need to slow down and really focus here. And then minus 160, I believe. But I love that you guys are with me and you're catching it. Thank you. And that should be your second derivative. So when you write in the little blank, please don't forget to put parentheses around your numerator so that I know, you know, the whole thing is a numerator and not just the negative 160. Next step, second derivative is 0 for what x? So we set the top equal to 0. When I do that, I'm going to go ahead and take out a 10 to kind of make this a little bit better. So that I have 3x to the 4th minus 8x squared minus 16. And this is factorable. I have 3x squared in the front here, x squared in the front here. If this is a 4 and this is a 4, my outer terms are 12x squared. My inner terms are 4x squared. I can get negative 8 as long as the negative 12x squared, and that's a positive 4x squared, then it'll work. So we set each factor equal to 0. This 10, and I know some of you guys tend to get confused when there's a coefficient in the front or a constant in the front. It doesn't really affect where that x intercept is. It just makes the graph taller or skinnier or shorter. Do you know what I'm saying? It doesn't change it kind of right and left. So we don't have to worry about that. If we say 3x squared plus 4 equals 0, I'm going to get x squared equals negative 4/3. What's wrong with that? You're never going to wind up getting a negative if you square something. So for that guy, we don't have any roots. They're imaginary. And for this one over here, x is going to be positive and negative 2. But we already knew that there were issues kind of at positive and negative 2 anyway. So the x's that are positive and negative 2. Sorry. It's undefined for what x? Positive and negative 2. So really, we should have a none on this because we know that that makes them undefined, right? It doesn't really make it 0, it actually makes it undefined. To check for concave up and concave down, we do our second derivative number line. I'm sorry, what, Ocean? You okay? Okay. For the second derivative number line, what numbers go on here? I heard somebody say it, -2 and +2. Anything else? No, we don't have any other critical numbers. I'm going to actually draw little asymptotes here so that I remember those are not actual points. Or maybe you could put a little star on it or something. If we put it in like a -3 into the second derivative, that's going to be a lot of thinking, which is fine. I'm happy to have you think, but I also want to save you some time. You could type it in your calculator and find out what you wind up with. I believe we wind up with a positive on the top. We know that the bottom will be a positive, so that's a positive. If we put in a 0, we're going to wind up with a -160 over a positive, so that's a negative. If I put in a +3, I'm going to get the same answer as if I'd put in a -3 because we're squaring things or making them to the fourth, which is an even exponent. So that's also a positive. So now we can see where our concave up and concave down is. Concave up, we're going from -infinity to -2 and from 2 to infinity. Concave down is from -2 to +2. How about inflection points? Do we have some of those? It looks like the concavity changes, but what's my problem with these two? Those are actually asymptotes, so there's not a point there. So we do not have inflection points. Vertical asymptotes, I literally just said we have asymptotes, so you know that those are asymptotes. And we know that they are at +2 and -2. So as we're approaching 2 from the left, I'm thinking about like 1.999. If I put in 1.999 into this and I square it and then I subtract 4, I'm going to get a negative tiny number, right? On the bottom. On the top, if I put in 1.999 and I square it, I get almost 4 plus 1. So I've got a number on the top divided by a negative teeny tiny number. Doesn't that give you like a really big negative number, like negative infinity? Yes? Wait. Yes. -2 from the left. Positive infinity? Negative infinity. Did I screw that up? You could just look at the graph. That is true. We're approaching 2, +2 from the left. Oh, yeah, negative infinity. We're good. Sorry, that was a little cheat. That's what it's going to look like. As we're approaching 2 from the right, the reason I'm trying to do this all by hand is because it is probable you will not get to use your calculator on your quiz. They'll all be fairly simple. 2 from the right means I'd have to think about 2.0001. So I've got almost a 4 plus 1, so I still have like a number on the top. And then this is going to be bigger than 4, so when I subtract it, I get a teeny tiny positive. So I've got a positive over a positive, but it's a regular number over a teeny tiny number. So I'm thinking infinity. As we're approaching -2 from the left, is the answer going to change? No, because we're squaring it. So again, I've got negative infinity and then positive infinity. Do I have a horizontal asymptote? I do. My degrees match up, and if you think about this, as we're approaching infinity, you can take off these little guys, remember? And if I cancel out my x squared, what do I have left? 1. So we are approaching 1 both ways. Bless you, by the way. This is negative infinity. This is positive infinity. And we don't have a slant asymptote because we have a horizontal one. Now we can graph it. I'm going to put my asymptotes on here first. A horizontal one at 1, and trust me, I've graphed this before. You're going to want every 2 boxes to be a unit. I'm going to put a number 1 right there so that Mrs. Major knows that those are my units. I also have asymptotes at 2 and -2, and those are vertical. So here's 2, here's -2. I've labeled so she knows that I know where everything is. Points that I know that there's a y-intercept at 0, -1/4. So that's a point I can put on there. I also know that this point is a local maximum. It's the highest it's going to get. So let's check out, let's see, at 0, it's concave down, and it looks like it's increasing and then decreasing. So the whole thing is concave down. It looks like it's increasing and then decreasing. Does that make sense to everybody about how I knew how to do that? To the left of -2, according to my little number lines, it's increasing and it's concave up. So increasing and concave up, I know that I'm headed to positive infinity as I approach -2. We found that out on our limits. And as we approach negative infinity, we're approaching 1. You could probably guess what this other one looks like, but if you wanted to know for sure, your +2 to the right, we are decreasing. It is concave up. As we approach 2 from the right, we're going to positive infinity. As we approach positive infinity, we approach 1. Ta-da! Questions on that one? Range. Thank you. I forget every time. Range. What is our range? Negative infinity up until, where's that stop? What's that y value? -1/4. So negative infinity to -1/4. Then it picks back up where? Almost at 1. Good. To infinity. Very good. Now we're done.
Why would you put brackets on 1/4?
Because you should, and I didn't do it. Good catch, Heather. That's a bracket because she knew it equals exactly -1/4. Nice catch. I don't think First Hour caught that. In fact, I know that did. Good job. Next page. Okay. Our domain, what can x not be? 4. So we go from negative infinity to 4 and 4 to infinity. Save the range for later. X-intercept, how do we get it? Top equal to 0. So if this were on a quiz, it'll be something that you probably don't have to have a calculator for. It'll be very simple kinds of factoring. Can we factor this? Thinking to get 12, it would be like 4 times 3, which is not going to get me a 6 if I add them or subtract them. Or 6 times 2, which isn't going to help me get that. Or 12 times 1, which isn't going to help me get that. We're stuck, so what do? Quadratic formula. Or you can plug it in your calculator. For the quadratic formula, when you work that out, trust me, you're going to get some crazy things, imaginary. So what's that tell you? There is not an x-intercept. Y-intercept, we take the 0 and plug it in for x. If I take a 0 and I plug it in for x, I wind up with 12 over -4, which is -3. So it's 0, -3. Derivative. Make some space, write tiny, keep it organized. So we have the bottom times the derivative of the top, which is 2x minus 6, minus the top, times the derivative of the bottom, which is just a 1, over the bottom squared. On the top, we need to FOIL. So we get first terms are 2x squared. Outer terms are negative 6x. Inner terms are negative 8x. So that should give us, what did I say, 6 and 8, so negative 14x. Last term should be positive 24. Distribute your negatives, so we have minus x squared plus 6x minus 12. All of that over x minus 4, the quantity squared. Put them together. 2x squared minus x squared is x squared. It should be cubed. Am I okay? Okay, just checking. But always double check, because goodness knows I make mistakes. Negative 14x plus 6x is negative 8x. And positive 24 minus 12 is going to give us a positive 12. There's your derivative. So when we write it in the blank, we want to make sure we have parentheses around our numerator, because that entire piece is the numerator, not just the 12. Let's know where the derivative is 0, so we set just the top equal to 0. Let's see if that thing is factorable. 6 and 2? If they're both negative, doesn't it work? Yeah. So x could be 6 or it could be 2. Is there anywhere where it's undefined? Whoa.
Yes. 4.
Yeah, if x was 4, we'd have an issue. So now for increasing and decreasing, we do our number line. And what numbers do I put on there?
2, 4, and 6.
All of them. 2, 4, and 6. Good. And I'm going to put a little star by the 4 so I remember that's where there's an asymptote. So if I plug in a 0 into the derivative, I'm going to get a positive on top and a positive on bottom, so that's a positive. If I plug in a 3, 3 squared is 9, minus 24 plus 12. Does that produce a positive or a negative? A negative over a positive. Good. If I put in a 5, it's going to be 25 minus 40 plus 12. That's still a negative divided by a positive. And if I put in a 7, it's going to be big, big, and we're good. Positive over positive. So there's your number line. So now we can tell where it's increasing and decreasing. We are increasing from negative infinity to 2 and from 6 to infinity. We are decreasing from 2 to 4 and from 4 to 6. Notice I didn't say 2 to 6 because at 4 the function doesn't exist. And I'm thinking, okay, increasing, decreasing, then there's a break. Decreasing, increasing. What does that tell you about 2 and 6? 2 is a maximum, 6 is a minimum. How do we get the y values that go with them? Into the original, very good. We want it in the original because that's the graph we're talking about. The maximum on the original is 2 comma something. So if I put a 2 in here, I have 4 minus 12 plus 12. So I have 4 over negative 2. So I have a negative 2. 6. 36 minus 36, so it's just a 12 on the top. 6 minus 4 is 2. 12 over 2 is 6. So my points are 2, negative 2, and 6, 6. Second derivative. I promise the third one goes faster than these. Am I going too fast? Are you guys okay? Okay. Second derivative. The bottom times the derivative of the top, which is going to be 2x minus 8, minus the top times the derivative of the bottom, be careful, 2 times x minus 4 to the first times the derivative of the inside, which is 1. All over the bottom squared, so x minus 4 is now to the 4th. Sorry. Okay. I'm going to follow that guy right there so that I have x squared minus 8x plus 16. I'm eventually going to do something with the 2x minus 8 there. Minus, I'm going to distribute the 2 to the x minus 4 so that I have the same problem, negative x squared minus 8x plus 12, and I've got a 2x minus 8. What do you guys want to do next? Do you think we might get there faster if we factor out the 2x minus 8? If I factor out the 2x minus 8, and you don't have to do this, you can do it the other way. But I think we will get some answers kind of faster, and we'll get something simplified faster. If I factor out a 2x minus 8, from the first term, I'm left with x squared minus 8x plus 16. From the second term, and remember this negative gets distributed to everybody, I'm left with minus x squared plus 8x minus 12. And now I'm going to do two things. If I rewrite this as 2, if I factor out a 2, does anybody see something I can do? I've got an x minus 4 as one of the factors of the top, and x minus 4 is on the bottom. You can take one out of the top, take one out of the bottom, so that now I have 3 of them on the bottom. I'm also going to combine like terms within this little guy right here. X squared minus x squared, negative 8x, positive 8x. So what I wind up with is I have 2 from right there times I have 16 and a minus 12. 4 over x minus 4 cubed. So I really have 8 over x minus 4 cubed. Are there any questions with how I did that? You would have gotten there the other way. It would just take you maybe a little bit longer. And there was like more algebra to do, so there's a greater chance for making a mistake. It wants to know where the second derivative is 0. Is the numerator ever going to equal 0? Nope. So it doesn't. It wants to know where it's undefined. 4, still 4. Concave up, concave down. So second derivative number line. What numbers go on that number line? Just 4. And it's an asymptote, so I'm going to remind myself by drawing an actual asymptote. If I put in, say, like a 0, I'm going to have a positive divided by a negative, so that's going to be a negative. If I put in, say, a 5, I'm going to have a positive divided by a positive, so that's going to be a positive. So now I can see concave down and concave up. We're concave up from 4 to infinity. We're concave down from negative infinity to 4. How about point of inflection? Why none? The concavity changed. It's undefined. There's an asymptote there. There's not a point there, so we say none. Speaking of asymptotes, that's our next sort of question. Vertical asymptote. We only have one of them, and it's at 4. So we can cross the second one out. As we approach 4 from the left, so I'm thinking like 3.9999. If I put that in on the bottom, I'm going to wind up with a teeny tiny small negative number. On the top, if I put in 3.999, I'm going to wind up with roughly sort of a big, is it a positive number? 3.994 minus, that's going to be 18. It's tricky, right? It's a little hard to figure out.
Probably a big positive.
Is it positive? It's a big positive divided by teeny tiny negative means that we're approaching what? Negative infinity. If we have 4.001, that bottom is now a positive, and the top part, positive?
Yeah.
Yes. So we wind up with positive infinity. Do we have any horizontal asymptotes? Hey.
Oh, I have not counted anybody absent yet because the shuttle and then I got busy with notes. Sorry, she's not here.
Okay, thank you.
Sorry.
Oops. Horizontal asymptotes. Okay, when we look at this, kind of look at these guys, sorry. Look at our degrees. They're not the same. We have an issue. When the top degree is bigger than the bottom one by 1, produces a slant. So I'm going to cross through horizontal asymptotes. And Mrs. Major knows I did think about it, and I know we don't have one. How do you find a slant asymptote? Long division. And this really isn't that bad. And actually, you could just factor and get this one. Couldn't you probably? Maybe, maybe not. Actually, you can't. Never mind. X squared minus 6x plus 12 goes on the inside. We're dividing by x minus 4. X times what is x squared? X. Multiply it back through. X times x is x squared. X times negative 4 is negative 4x. What's my next step? And we're subtracting everything, which is why I put it in parentheses. X squared minus x squared is nothing. Negative 6x minus negative 4 is negative 2x. Bring down the plus 12. X times what is negative 2x? Negative 2. And that's the equation of a line. You could probably like stop now. But if you wanted to actually finish it out, multiply it through, la-di-da-di-da, we get negative 2x plus 8, and then you get, you know, whoops, about a remainder. The remainder we can just sort of forget about. This is the piece we're concerned with. So y equals x minus 2. I'm sad that I've written my asymptote right there.
How'd you know there was a slant?
Because the degree of the top is 1 greater than the degree of the bottom. Okay, let's draw it. I'm going to go ahead and start with the asymptote because that's where we left off. This line crosses at negative 2. Negative 1, negative 2. And it has a slope of 1. So rise over run. So this is my asymptote. I know that I have a vertical asymptote at 4. Other things I know that there's a y-intercept at 0, negative 3. I didn't even put that on last one. I also know that there is a local max at 2, negative 2. And I know that there's a minimum at 6, 6. So we're just going to pretend that actually made it onto the graph. Sorry. I know that down here at 2, I'm increasing and then decreasing, and the whole thing is concave down. So increasing, decreasing, the whole thing is concave down. I know that I'm approaching the asymptote as well as negative infinity according to the limits we figured out. At 6, I know that it's decreasing and then increasing. I also know it's concave up because it tells me so. I know that I'm approaching the asymptote over here, and I know that I'm approaching positive infinity right there. So there's your graph. Questions on that one? All right, last one. This one goes faster. I wanted you to see one piecewise. Do what? Range! Dang it! I'm the worst! I'm so bad about it. If you miss it on your test, I'll probably just count it right because I'll forget to grade it. Not really. Make sure you do it.
Oh.
Not really. Make sure you do it. What is the range? We're going from negative infinity all the way up till, what's that y value? Negative 2. And then it skips until, when's the next time we have something? Yeah, it's 6. Actually, that's our minimum. And I shouldn't have drawn that up there. I should have drawn it like that. 6 to infinity. Okay. Last one, I wanted to expose you to a piecewise function. These actually aren't that bad. The domain is asking about x's. We want to know what x cannot be. For this, it's a line, so x could be anything. For this one's a parabola, x could be anything. And our restrictions say it's everything up till 3, including 3, and then we take off and we go off in the other direction. So we're covered. It's negative infinity to positive infinity. X-intercept is where we set y equal to 0. So I have 0 equals 9 minus x, and I have 0 equals x squared minus 3. Why did I write none even though I got 3 answers? Because for this guy right here, in order for him to equal 0, x had to be 9. Does 9 fall within those restrictions? No. It only exists left of 3. So 9 is like not even part of that graph anymore. Positive and negative radical 3. Neither one of those are bigger than 3. So we don't have any x-intercepts for this piecewise function. Does that make sense to everybody? So these are your notes. If you need to make a note about that, do it. I'm going to say not in restrictions. Okay? Y-intercept is where x is 0. So if I take a 0 and I plug that in there, what do I get? 9. And why am I stopping there? Why am I not putting 0 into this one? Right, the restrictions. X has to be bigger than 3. So if I plug in a 0, well, 0 is smaller than 3, so it can only go on the top one. Derivative. The derivative of the top function is what? So negative 1 when x is less than or equal to 3. And how about the derivative of the bottom one? 2x when x is greater than 3. Nothing to it. It's actually easier than the fraction ones y'all hate. It wants to know where the derivative is going to be 0. Is negative 1 ever going to be 0? Nope. So that one doesn't work. 2x could equal 0 if x was 0. But, very good, it's not in the restrictions, so we just say never. Or none. Where is it undefined? Nowhere. We're good. Increasing and decreasing. We wanted to go ahead and do our number line. But what numbers go on here? 3, definitely. How'd you know that, Ocean? Yeah, that's kind of where our issue is. That's where the graph is changing. And we didn't have any other critical numbers to put on there. So, we say, okay. If I plug in a 2, where am I going to plug that in? Derivative, regular function. In the derivative, the top function or the bottom function? The top, because that's where x is less than 3. So if I plug in anything, I wind up with a negative, because it's negative 1 the whole way. And if I put in a 4, I need to put it in the second one, because that's where x is greater than 3. So 2 times 4 is a positive 8. So now we have increasing and decreasing. We are increasing from 3 to infinity, and we are decreasing from negative infinity to 3. Now here's the question. Is there a point that exists right at 3? Yes. And what we need to find out is, right at 3, well, yeah, we need to look and see, are these guys even connected? 9 minus 3 is 6. 3 squared minus 3 is 6. They actually are the same. You can't even read that. Those are 6's. Sorry. They're actually going to wind up at the same point. So if we are decreasing and then increasing at 3, what do we have here? There is a local minimum at 3. We do not have a max. 3 comma what? How do I get to something? Plug it in. Top function or bottom function? Top, because that's where 3 is allowed to exist, and it's 6. Second derivative. What is the derivative of negative 1? 0. What's the derivative of 2x? 2. Does everybody see how this is working for your derivatives on a piecewise? Great. Second derivative is 0 for what x? None? Pretty sure it says it's 0 right there. So for everybody less than or equal to 3, or from negative infinity to 3. Is there anywhere it's undefined? Nah, we're good. All right, second derivative number line. What numbers go on there? 3, right? If I go and plug in numbers less than 3 into this, I get a 0. What do I put over here? It's not a negative or a positive. I'm going to X it out, and here's what it's telling you. According to the first number line, it means it's decreasing. And it's neutral. It's some sort of constant. It means it's a straight line on that part of the graph. It's a straight line. It's not concave up or concave down. It's a straight line. Let's plug in 4. Plug it in the bottom. We get a positive 2. So we're concave up from 3 to infinity. And we are never concave down. How about an inflection point? None. Do we have any vertical asymptotes? There's nowhere it's undefined. We're good. No horizontal asymptotes. We're solid. No slant asymptotes. We crossed them out so Mrs. Major knows we thought about it, but we know there's not any. And now we graph. I know that there's a y-intercept at 0, 9. I know that, let's see, that there's a local minimum at 3, 6. Let's see here. Up until this point right here where this local minimum is at 3, I know that I am decreasing, and I also know it's a straight line. So that should be straight. Sorry, it's not very straight. Pretend it is. And then from 3 onto the right, I'm increasing, and it's concave up. Done. That's it. So don't shy away from those piecewise functions. Sometimes they're easier. Yes, thank you, range. Dang it, I'm the worst. What is the range? We have nothing, 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 nothing. Oh, something. Where do we start? 6. All the way to infinity. Thank you, Heather. And bracket. Oh my gosh. Heather, you're going to have to start teaching this class. Alrighty. That's that. Let me go ahead and turn this off.